Inertia and gravity come in the middle of our VPIGS mnemonic. Gravity is easy to identify. That is, if we have a mass, it'll be subject to a force exerted in a downwards direction, and that force due to gravity will be equal to the mass times that gravitational constant g. And g is 9.81 meters per second squared, near enough, at least near us on the surface of the Earth. Inertial force is really a fiction. So if we're trying to track down that Fi, keep in mind that it is a fiction. It's a force that we're going to use to represent how fast an object is moving. So if we have a chunk of mass and it's moving across the page very quickly, we could ask ourselves, how big a force would it take to stop it before it got off the page? If this is our mass sitting here, and it's actually moving fairly quickly with a velocity, capital V, off in this direction, then we'd like to know how large a force we have to apply to it to make it stop before it disappears off the edge of the screen. Well, we're going to have to change its x velocity by capital V, and we're going to have to do that in a short time, delta t, that's going to be proportional to 1 over the velocity. Because the bigger the velocity is, the faster it moves off the page. So that inertial force, which is going to be some mass times acceleration, would wind up being proportional to the density for the mass and the velocity squared. Delta U over delta T is going to be V over 1 over V is going to give us that velocity squared. So because it's moving fast, we need a large force. And because it's moving fast, we need to stop it in a much shorter time before it gets off the page. Now, this inertial force is a fiction, but it's going to allow us to compare the forces that we can generate with the various things like viscosity and gravity, surface tension and pressure, to the velocity that the particle's already moving and how much force it would take to change that velocity substantially inside the region of interest. Now, gravity we also think we understand with this mg approximation, but keep in mind that gravity is a fairly complicated phenomenon if you're arguing it from a physics standpoint. And so when we use this g equal to 9.81 meters per second squared, it's only going to apply near where we are, sitting on the surface of the Earth. Fortunately, most of the work that we do, we're sitting on the surface of the Earth. So we can use these models for inertia and gravity forces to fill out 2 more of the VPIGS forces that we're trying to keep track of.